Namaskar, my dear students. Today in the dental materials section, we will be discussing about soldering and welding. In dentistry, some dental appliances or dental prostheses, they are sometimes fabricated in separate parts. Then they are joined together by the process of soldering or welding. So we will discuss these processes in detail. So let's begin. Now, before going into the details, let us discuss some very important terms that I will be using frequently. The first is welding. What is welding? It is the joining of the two pieces of the similar metal without any addition of another metal. So that means there is no filler metal. The metal pieces, the substrate metal, they are heated to a high enough temperature so that they join by melting or flowing. This is called as welding. The next important term is soldering. What is soldering? In this, the metal parts, they are joined together by a filler metal. A filler metal is melted between them at a temperature below the solidus temperature of the parent metal. Okay, and this is done below 450 degrees Celsius. This is very important, the temperature. The next term is the brazing. In this also, the metal pieces, they are joined together by melting a filler metal between them, and this is done above 450 degrees Celsius. So here the temperature matters. In dentistry, the joining of the metal parts, it is mostly done above 450 degrees Celsius. So that means we are ideally using brazing for all the procedures, but commonly we use soldering. Next is the substrate metal. It is also sometimes called as the basis metal or the parent metal. It mainly refers to the metal parts that are to be joined, and the composition of the substrate metal is important because it will determine its melting range. You know, the soldering should always take place below the solidus temperature of the substrate metal. In dentistry, the alloys that can be soldered or welded, these include gold, silver, palladium, nickel, cobalt, titanium, etc. Coming to the next, that is dental solder. Dental solders are the alloys that are used as the filler or the intermediary metal to join the two or more metallic parts, that is the substrate metal. Now, this dental solder should possess certain ideal requisites for their application. We will discuss them in detail. So here we have the ideal requirements of the dental solder. First is that it should melt at a temperature below the solidus temperature of the parent metal. Okay, that is the main requisite. Second is that it should it should wet and flow freely over the parent metal. Third, its color should match that of the metal being joined, that is the parent metal. Then it should be resistant to tarnish and corrosion. It should resist pitting. Any kind of pitting should not be there during heating and application of the dental solder. Next, let us discuss the applications or the uses of the solder in dentistry. You know, soldering is used in many ways. First is that for soldering wires in orthodontics. Second, in periodontics, when we are making the fabricating the space maintainers. In fixed prosthodontics also it is used, first for joining the various components of the FPD, for repairing of perforations in the crown and the bridge, then for developing any contact points in the crown which is missed, for cutting and rejoining any ill-fitting distorted bridge. Also, it is used in RPD, in the removable partial prosthodontics, for soldering of the clasp. Now we come to the classification or the types of the solders or the brazing materials. The solders can be divided into two major groups, that is the soft and the hard. You know, the soft solders, they have a low melting range of about 260 degrees Celsius, and they can be simple done by a hot soldering iron. They also lack corrosion resistance and they are not at all suitable for dental use. While the hard solders, they are commonly used in dentistry, they have a higher melting range, they have greater strength, hardness, And this is done with the help of gas blowtorch or electric furnace. They are also used for industrial purpose and in the jewelry. Okay, now they are further of two types, the gold solders and the silver solders. The gold solders can also be yellow or white. First, if we discuss the composition of the dental solders, we talk about the gold solders. Depending on the fineness, the gold can range from 45 to 81%, silver 8 to 30%, copper 7 to 20%, tin or zinc 2 to 4%, and phosphorus in traces. Second are the silver solders. Silvers are in 10 to 80%, copper 15 to 50%, zinc 4 to 35%, cadmium or phosphorus in traces. Properties of the dental solder or the brazing material. First, if we talk about the fusion temperature of the solder should be at least 50 degrees Celsius lower than the parent metal. And if we talk specifically, the gold solders, they have the fusion temperature of 690 to 870 and silver 620 to 700 degrees Celsius. Now flow, as we talked in the requirements, a good flow and wetting should be there with the parent metal for a good bond. The factors that affect the flow, first is the melting range, second is the composition of the parent metal. The gold and the silver, they have better flow as compared to the nickel based alloys. Then oxides, any kind of oxide layer will reduce the flow. Surface tension of the solder. Next we come to the color. We also discussed in the requirements that the color should match with the parent metal. If we talk about the gold, gold is yellow to light yellow to white in color. Tarnish and corrosion resistance. This resistance increases as the gold content increases. The silver solders, they have reduced tarnish resistance when compared to the gold alloys. Mechanical strength, if we compare, the gold solders, they have adequate strength and hardness, and it is also comparable with the silver solders. Microstructure of the solder joint. If we talk about the microscopic examination of the solder joint, the solder alloy should not combine excessively with the parent metal because it may lead to the formation of a third metal which has inferior properties. Flux. What does flux means? Flux is a Latin word which means flow. So for a solder to wet and flow properly, the parent metal must be free of oxides, and this is done with the help of a flux. Functions of the flux. First, it provides a protective coating around the parent metal. It also dissolves or remove any kind of oxide on the parent metal. Then to influence the surface tension equilibrium, and it also allow the melted solder to wet onto the adjoining alloy. Coming to the types of the soldering flux, they can be divided into three types depending on the action. Okay, first they are protective. Now these type of solder, they cover the metal and prevent access to the oxygen so that no oxides can form. Second are the reducing. They will reduce any kind of oxides present and they will expose the clean metal surface. Third are the solvent. They will dissolve any kind of oxides which are present on the metal surface. There are mainly two commonly used dental fluxes which are used. First is the boric and the borate compounds. They are mainly used with the noble metal alloys. For example, the gold alloys. The composition is the boric acid is 35%, borax 55%, silica or sodium carbonate 10%. This flux is mainly available in the form of powder or cakes or as a thick paste. Second, come to the fluoride fluxes. They are like the used for the base metal alloys for soldering chromium cobalt alloys. They are also used in combination with the borates. They help to dissolve more stable chromium, nickel and the cobalt oxides. But one thing, they should be used carefully around the porcelain because it can attack the porcelain also. Composition: potassium fluoride 50%, boric acid 35%, borax 8%, silica 7%. Anti-flux. There are times when we want that the solder should not flow out of a specific area. So what to do now? This anti-flux, it limits the area of the flow of the solders during the soldering. The anti-flux is applied first to the surface before the flux or the solder is applied. The example of the anti-fluxes are the graphite, that is the soft lead pencil, rogue, that is iron oxide, whiting, calcium carbonate in alcohol or water suspension. Many a times you get short notes on flux and anti-flux, so these topics are very important. Next, we come to the technical considerations. First is the heat source, which is very important part of the brazing. Two heat sources can be used. First is the gas air or the gas oxygen torch, and second is the oven, that is the furnace brazing. The flame should have high temperature and also the high heat content. The heat content, it can be measured in BTU, per cubic foot of gas, that is calorie per cubic meter, British thermal unit per cubic foot. In the technical consideration, the third point is the gases which are used in soldering. First is the hydrogen. Hydrogen has the lowest heat content, therefore the heating would be very slow. Second is the natural gas. It has the heat content 4 times that of hydrogen, but it has non-uniform composition. Third is acetylene. It has the highest flame temperature, but it has a major problem that in a part of the flame, the temperature may vary for more than 100 degrees Celsius. It is also chemically unstable and decomposes readily to carbon and hydrogen. Third is the propane. Propane is the best choice. It has the highest heat content of 2385 BTU. Last is the butane. It is more readily available in some parts and it is just similar to the propane. Both propane and the butane are uniform in quality and also water free. So if we compare all the gases, the heat content of propane is highest, that is 2385, and it is also stable and water free. So it is the best choice. The flame and the temperature. The torch flame can be divided into 4 zones. You may get a short note or many MCQs are formed from this chapter. First is the cold mixing zone, that is the internal, as we can see in the picture. This is the zone of unburned gases. Second is the partial combustion, that is the oxidizing zone. Third is the reducing zone. And fourth is the oxidizing zone or the burned gas zone, that is the outermost. The reducing zone is used to heat the soldering assembly, one of the multiple choice question. Flame should be maintained in place until the filler metal has flowed completely into the connection. The time is very important. If there is insufficient time, what will happen? It will increase the chance of incomplete filling of the joint. And second, if we are prolonging it, what will happen? The longer time, it increase the possibility of diffusion between the parent and the solder metal. Both of the things, they lead to a weaker joint. Types of the techniques of the soldering. There are 2 types of techniques that can be used. First is the freehand soldering. Most of the soldering procedures carried out in orthodontics, they fall under this category. What is in freehand? Freehand means the parts are assembled and held in contact manually, okay, while the heat in the solders are applied. Second is the investment soldering. It is carried out whenever the area of the contact between the metallic parts is bigger, is larger, and whenever precision is needed in the joining the metal. The procedure, it involves embedding the metallic parts in an investment, leaving a gap of about 0.13 millimeter between the metals. Next, we come to the steps involved in the soldering procedure. First is the selection of the solder. Second is the cleaning and polishing of the components, that is the substrate metal, assembly of the prosthesis in the soldering investment or whatever method you are using, then application of flux, preheating the components assembly, placement, that is heating and introduction of the solder, application of hot gas flame to join the solder joint and the solder, then cooling of the assembly followed by quenching in water, then cleaning of the solder joint, and finally finishing and polishing. Next is the gap width. The gap between the two metal parts is very important. It should be optimum for the proper flow of the solder, giving strength to the joint. Gap width ranging from 0.13 to 0.3 millimeter has been suggested optimum. If the gap is too narrow, strength is limited because porosity will be there by the incomplete flow of the solder metal and flux inclusion. Second is, if the gap is too much, too great, then what will happen? The joint strength will again be compromised because the strength of the solder will take place at the joint, and there is also a tendency for the parts of the metal to draw together as the solder solidifies. Pitted solder joint. This pits or the porosities at the solder joint are often seen during finishing and polishing. What are the reasons behind it? First is that the volatilization of the lower melting components, and second is that improperly melted or excess flux that is trapped in the solder joint. How we can avoid such kind of pitting? First is that the less flux is applied and heating should be discontinued as soon as the flux and the solder, they are well melted and flowed into the position. Next we have the topic welding. As we discussed earlier also, the joining of two or more metal pieces by applying heat, pressure or both without any filler metal to produce a localized union is called as welding. Now, indications of welding in dentistry: in orthodontics to join the structures like bands and brackets, in periodontics to weld the bands for space maintainer, in prosthodontics to join the wrought wire clasp and repair of the broken metal partial dentures. Principles of spot welding. Heat and pressure, they are the two main basic principles which are involved in spot welding. What happens in this, that the electric current is made to pass through a step down transformer to obtain a low voltage and high amperage current that is conducted through the two copper electrodes on either side of the metals being joined. Now let us know the step-by-step procedure of the spot welding. First, a proper electrode for the thickness or the shape of the material to be welded are selected. Second, the electrode of the welder, they are cleaned so as to remove any kind of carbide precipitates. The metals to be joined are placed between the two electrodes and the switch is turned on. The electrode pressure can be maintained for a few seconds to help to get a good joint. Coming to the advantages and disadvantages of welding. Advantages: the spot welding is very successful for the formation of overlapping joints of the stainless steel or other chromium containing alloys. Second, welding is also preferred over soldering if the heating cycle must be very short in order to prevent any changes in the physical property of the components to be joined. Second are the disadvantages. The weld joints, they are more susceptible to corrosion, that is called as weld decay. Okay. Second, too low current or too short of a time, it results in a weak joint. Laser welding. Laser welding is mainly used to join the titanium components. The commercially pure titanium is used for crowns, bridges, and the partial denture frameworks. It is a very highly reactive metal in the air. So at temperature that are used for the soldering, the thickness of the titanium oxide layer increases. So it is very difficult to solder the titanium. So for this we use the laser welding. There are many commercially available lasers available. What is it contains? The unit mainly contains a small box that contains the laser tip, an argon gas source, and a stereo microscope with lens. This corrects the alignment of the laser beam. The maximum depth the laser can penetrate is 2.5 millimeter. The heat generated is also small, so the parts can be handheld during the welding. It is also done close to the ceramic or even the resin facing without damaging it. Advantages of the laser welding: first, there is a lower heat generation. Second, there is no oxide formation because of the inert argon atmosphere. Third, the joint will be composed of the same metal as the substrate metal, so it also preserves the biocompatibility. It also reduces the chances of galvanic corrosion. Now, the laser welding, as I told you, it can be done close to the resin or ceramic portions without the fear of damage. So that's all for this topic. I'm sure this video will really help you to prepare this topic. Please like and share with your friends and your juniors. You can also comment your topics which I should take in my next videos. Wish you success today and always.